And then all I wanted to do was friggin' cut the thing in half. Right plane, top plane, insert, cut with surface. Yep, that works. I just wanted to see what these angles were. So if I pick this angle, and then, oops, and this angle, what do we get? 38 degrees. Like, how accurate is that? Is it 38.0? Edit, sketch, convert entities, dimension. $38 degrees exactly. Okay. How deep are these? Are we in inches or millimeters? ISO units, we're in millimeters. Let me switch to inches. What does it do then? It's still not a wonderful number. Oh, those are ugly numbers. Wow. What about the top number? Okay. So, suitable for A-type V-shaped pulley, A-type. What we want to know is what an A-type is. Pulley type. A-type. Difference between A and B pulley. So an A-type is a 1/2 inch wide. Don't want to sign up. Belt. A-type belt. Yeah, A belt's a 1/2 inch wide. Okay, so the groove is correct. So let's drop this out and get done here. So 38 degrees. And it's a 1/2 inch wide at the top. So we're going to go back to this one. Window. And we're going to go on the right plane. And we are going to So what I did there is I actually picked the midpoint of the line and then picked the silhouette edge and picked midpoint as my mate. So it mated the midpoint of the line to the midpoint of the silhouette edge. And this is 25.4 divided by 2. Should have known that. And really could have done it a different way anyways. Dang it. Come on. What? Oh, I'm pushing the Windows button. Gosh, I couldn't figure out what was going on. Okay, so then we're going to do 38 degrees here. And let's go back to our other and see how deep those were. Sketch 1.468. Hello. 0.468 inches. I don't know what that is in degree or in millimeters. So sorry guys, I'm not very talkative. I just got so wrapped up on my work here. So basically we're going to turn this into a block real quick. So where's my block toolbar? There it is. And insertion point is going to be something like that. And that's my block. V groove type A. And so now that it's a, is it still happy? Okay. And we should be able to pick that. Of course not. Alright, what I should have done in the first place was made an axis. Look at that. Starting to look like a pulley now. So what I'm going to do is I'm just going to borrow this each time. This in the right plane, and drive sketch. I also could insert the block, but whatever. Drive sketch block. I'm sure there's a reason to do one or the other. Sketch tools. Where is it? Sketch entities. Why am I not finding it? Insert. Drive sketch. Alright. We're going to place this down on the midpoint, like so. And, of course, Solidworks is going to act up. Yeah, it's kind of acting funny here, so I'm not going to do that. I'm going to discard changes. I'm going to, oh, I know what I can do. I can just go here and copy the, I don't know why I was having such a hard time, guys. So, we will insert block, 1, 2, 3, 4. 4 more of those bad boys. And we're going to go like this, right there, and right here, and right sometimes when you start a workflow and you just don't know how it's going to go. It's not always the smoothest. It's not like I do pulleys for a living. Otherwise, I'd probably have this down. So, let's see. Did that make me happy? Sure enough. And then this has a keyway in it, but I'm not going to draw it because I don't know what it is without ordering it. Manual measurement, plus or minus 1 to 3 millimeters. That's funny. I'm going to leave this part. Actually, does it have a part number? I don't see. Oh, there's the part number. Straight from Amazon's mouth. Whoa. Don't know what that extra bit of information was. Alrighty, so we're done with that. So we now have our pulley, and what's rad is it's 5-stage, so I can get all kinds of speed variations on there. We're going to disregard that one. Oh, shit. It is machined out on the back. 1, 2, 3, 4 steps in it. Look at the chatter marks on that bad boy. Jeez. Alright, guys, we're going to go back and fix that real quick. So it looks like... let's go back and fix it on the original Revolve. Looks like... How many steps are there? 1, 2, 3. So 1, 2, 3. So, looking at the picture, it looks like it goes like this. I have got no flippin' clue what they did here. We'll make the overlap like 25.4 divided by 4 gives us what? 6.35. What would those Chinese guys do? Yeah, I just got no clue. 6. 6. So this is a bit of a guessing game till you actually get the pulley and you can measure it. This really won't affect my design. It just is bullshit that they don't have these numbers. Looks like it's about 4 millimeters. And the step looks like it's about 2. No, it's got to be 3, 4 also. And who knows what this inside... I just don't know. 45. And then we'll is the same, so that, and that are all equal. So then what they've got on the inside here, so here, oops, here they have a chamfer. Looks like it's about a, I'm mispicked. There ain't no 10 millimeter chamfer. It looks like it's, we'll call it a 4 millimeter. No, it's not even that. 3 millimeter chamfer. And then they left sharp outer edges, but they were smart enough to round the inside, so we'll call that like 2 or 3. We'll see. 2. It's this one, that one, and this one. They all rounded. So I think that's our pulley there. We're like at an hour here, so I'm gonna hang it up for right now. We'll start working on assembly tomorrow because we still got to do the buffing wheels, and it's late at night here. So I'm gonna finish it off here, guys. Gonna leave my pulley. I'm gonna combine that onto the other sheet so I know what I did for research. And I know what to buy. There's my pulley. And I think we're going to call it good, guys. We'll pick this up tomorrow, and I will talk to you guys later. Bye.